So hey everybody, this is Mr. Bells again. The video I'm going to show you right now is a quick little, I'm hoping under 10 minutes right now, a short little video on being able to factor for more complicated things. So we're going to talk about when we have to factor trinomials while factoring like a dentist, and we're going to try and do something called difference of squares. So that's what we're doing right now. Hopefully this will work out great for you guys. And here we go. So you guys can see this around here. So what does it mean when we're doing differences of squares? So when we have a quadratic equation like this, or a quadratic expression like this, and this is a perfect square because x squared is x times x, and this is a perfect square because 25 is 5 times 5, and the perfect square simply means that there's a number or a letter that multiplies together by itself to get this. The factors are pretty easy. We just have x and an x, and then because that's the square root of x squared, and then here square root of 25 is 5, so we simply put in a 5 and a 5, and one of the signs is positive and one of the signs is negative. And you can see that when we FOIL this, first times first is x squared, outside is a negative 5x, and inside is a positive 5x, and those cancel each other out. So positive 5x and negative 5x. And that's why there is no linear term right up here. And remember, linear term means a term with just an x in it. Okay, so the insides cancel each other out, and now you just have 5 times negative 5, which is x squared minus 25, which is what we started with. Okay, so when you see perfect square, and a subtraction sign, I want to make sure it's clear. It only works when it's a subtraction sign. That's why it's called a difference of squares, not an addition of squares. Okay. If it was a positive, then we'd have either a plus 10x or a negative 10x in the middle. That doesn't work. So let's take this one. So I have x to the fourth minus 81. And I know that looks a little trickier, but this is a perfect square because x to the fourth square rooted is x squared times x squared. And 81 square rooted is 9. So this should break it down into x squared minus 9 and x squared plus 9. And so you're like, yay, I'm done. But if we look carefully, that's perfect square and that's perfect square, and that's an addition sign. So we know that it doesn't work for addition of squares, but it does work for a difference of squares. So this actually breaks down even further into x plus 3 and x minus 3, because that's a perfect square and that's a perfect square too. So the whole completed factorization for this looks like this: x plus 3 times x minus 3 times x squared plus 9. Okay? So I'm still going to go along. I'm going to try this one right here. This is 3x squared minus 75. And I'm looking like, well, x squared is a perfect square, but 3x squared isn't a perfect square. And 75 is not a perfect square. But that's where I have to remember the dentist. So again, the first rule in factoring everything is, can I pull something out that's common? So I'm going to go ahead and pull a 3 out. When I pull a 3 out, I'm left with x squared minus 25. And that is the same thing I had over here for this one. So then I know that it's 3 times the quantity of, you guys tell me, right? You can say it out loud even in your little video. Yep, x minus 5 and x plus 5. And it doesn't matter if you put x plus 5 and x minus 5 or x minus 5 and x plus 5, as long as you have one of each sign. Okay? And that's, again, as far as you can factor that down. So let's go to this one. This one's going to be a little bit more complicated. You're like, okay, I got 2x squared plus 10x plus 12. I'm like, Oh yeah, remember again, dentist, that's the first rule of factoring. So I'm going to go ahead and pull a 2 out. I can't pull an x out because even though this term has an x and this term has an x, this term doesn't have an x. So I pull the 2 out, and I'm left with x squared plus 5x plus 6. And now I'm going to see if I can factor this quadratic. Well, it's not a difference of squares, but it is stuff like we factored before. So I need factors of 6, which are 1 and 6 and 2 and 3. And I need them to add, because that's a positive. They need to be the same sign. We need them to add together to get positive 5. Well, that's pretty easy. That has to be the 2 and the 3. So I'm going to get an x plus 2 and an x plus 3. Cool. This one over here, again, a little bit more complicated, but I think you need to see some of these to do some of the stuff that I put in Big Ideas online assignments. So I'm going to go ahead and go, 4 goes into 28, and 4 goes into 72. It goes into all of them. Now, if you didn't know that, hopefully you can do a quick little math check on your calculator if you need to. So I'm going to pull a 4 out, and then I also have an x to the 4th, an x cubed, and x squared. So the biggest one of those, right, the greatest common factor for that is x squared. So I'm going to pull a 4x squared out, and now I'm going to write what's left. So on this first term, what's left is an x squared. On the second term, it's still a plus sign, right? Plus. So 4 times what is 28? We know that's a 7. X squared times what is x cubed? We know that's an x. So now I have x squared plus 7x. And then 4 into 72. And again, if you can't do that in your head, that's totally okay. You can go ahead and say, I can do that on my calculator. Let's see if we can do that. And I get 18. Sorry, that's my phone. Minus 18. Okay, and I don't need to have any x's, because if I had any more x's here, then multiplying them with x squared would make it bigger than x squared, and I just want it to be exactly that. So now I'm left with this, and I'm like, okay, well, 4x squared, I can't break that down any further. But can I break this thing down? Well, I look at factors of 18. Those are 1 and 18, and those are 2 and 9, and those are 3 and 6. Those are all my factors of 18. Because this is a negative, that means I have one of each sign, which means I need a difference of these two sets of numbers. So what's going to give me a difference of 7? Well, 2 and 9 give me a difference of 7. And I know I need this 7 to be positive, so that means the 9 has to be the positive one. So I get x plus 9 and x minus 2. Again, if I multiplied all this stuff back together again, it would obviously equal what I started with. So that is a complete factorization of that. So hopefully these ones will help you with completing a little bit of assignments up there. Again, everything that I put in the video so far are things that are going to benefit you. You just got to make sure you take good notes. Ask me questions when we're together, and if you get stuck on some things and you've really gone through it and taken good notes, remember, talk to some other people in class. You guys have easy ways to be able to contact each other. Send me an email, ask for a private Zoom or Google Meet. Just stay on top of this stuff, and we're going to be good. And we'll talk to you guys later.